Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon, everyone. So, today we are going to continue with our chapter 7, Ionic Equilibria, with our subtopic 7.1, Acid and Bases, part 2. Okay, so there are a few things that we are going to cover for today. The first one, we are going to explain qualitatively salt hydrolysis and write hydrolysis equation and classify the salts from the reaction between strong acid and strong base, strong acid and weak acid and strong base. And we are going to also define the buffer solution and describe how a buffer solution control its pH. And we are going to write the Henderson-Hasselbalch equation for a given buffer solution. And actually there is a calculation for a buffer solution, but I am going to do a different video for it. But for class K72, K73, which you guys have a lab with Point Ila this evening, so Point Ila will cover that for you. But right now, I'm still going to make the video for the buffer calculation so that you can refer to it in a later time. Okay. Okay, so let's get started with salt hydrolysis. Okay, so what is actually salt hydrolysis? So salt hydrolysis is actually the reaction of an ion or a cation of a salt with water. So how are we going to get this salt? Okay, so this salt is actually we got from the neutralization process from an acid and base. So an acid and base, they undergo neutralization process to form salt and water. Okay, so this salt will further dissociate to form an ion and cation, and this anion and cation from the salt will hydrolyze with water to form uh, to what we call it, to show its properties, whether it's acidic, basic, or neutral. Okay, so let's see. So there are actually uh, two types of hydrolysis of salt. Okay, so this salt actually they completely dissociate into cation and anion, right? So this cation will hydrolyze with water, okay, and anion will hydrolyze with water as well. So let's look at the cation hydrolysis equation here. So we got cation hydrolyzed with water to form MOH and hydrogen ion or hydronium ion. Okay, so this hydrogen ion is actually contribute to the acidity of the solution, so it causes the solution to be acidic. Okay, so this anion also undergoes anion hydrolysis, where it will form hydroxide ion, which causes the solution to be basic. Okay, so this to explain why there are a few types of salts from the neutralization process. The first one we have acidic salt, the second one we have neutral salts, and the third one we have basic salt. And this salt is actually produced by different acid and bases, by different what we call it, reaction of acid and bases. Okay, so let's look at the acidic salt first. Okay, so look, when you look at acidic salts, it is actually produced by the reaction of weak base and strong acid. Okay, so we have an example here. Weak base is NH3 and the strong acid is HNO3. So when this weak base and strong acid undergo neutralization process, they will form NH4NO3 salt and water. Okay, so this salt will be completely dissociate into NH4 cation and NO3 anion. And this cation and anion will undergo hydrolysis with water. Okay, so let's look at the cation first. So NH4 cation is actually a very strong conjugate acid of NH3. So since NH3 is a weak base, it forms a strong conjugate acid, which is NH4 cation. Okay, so this conjugate acid of NH3, which is NH4 plus cation, will act as a Bronsted-Lowry acid, which it can donate a proton when it hydrolyzes with water molecule. Okay, so when it undergo the cation hydrolysis reaction, it will donate a proton to a water, okay, to form hydronium ion here. So if you look at the cation hydrolysis equation here, so the NH4 plus ion react with water, hydrolyze with water to form NH3 and hydronium ion. So if you look at here, NH4 plus act as a bronzed lauric acid by donating a proton to the water to form a hydronium ion. So now hydronium ions are formed. Okay. So now let's look at what happened to the anion. So the anion, NO3 minus, is actually a weak conjugate base of a strong acid HNO3. So the strong acid form a weak conjugate base NO3 NO3 minus anion. So this NO3 minus anion, since it is a very weak conjugate base, it has no affinity for hydrogen ions and no tendency to hydrolyze with water molecules. So no reaction in anion for anion, okay, for this salt, okay. So only cation hydrolyze with water to form hydronium ion. So this hydronium ion contribute to the acidity of the solution. So it will make the solution, the pH of the solution less than 7. So this is acidic. So this is what we call, NH4NO3 is the acidic salt. Okay, because it is formed by the reaction of weak base and strong acid to form an acidic salt. Okay, this is the explanation why NH4NO3 is an acidic salt. Okay, because cation here is a strong conjugate acid and it hydrolyzes with water to form hydronium ion, which contribute to the acidity of the solution of the salt. Okay, now let's go proceed to the second type of salt, which is the neutral salt. Okay, so the neutral salt is formed by the neutralization process and reaction of strong base and strong acid. So we have here strong base is sodium hydroxide and strong acid is the hydrochloric acid. Okay, so this neutralization process reaction will form a sodium chloride salt. Okay, so this sodium chloride salt will further dissociate completely to form sodium cation and chlorine anion. Okay, and this both of this ion will need to hydrolyze with water. Okay, to form either hydronium ion or hydroxide ion. However, for sodium cation, okay, since it has a very low polarizing power because of its low charge and large size, it cannot bond strongly with water molecules. So it cannot hydrolyze with water molecule. So it cannot undergo hydrolyzation with water. So no reaction happen for Na plus cation. Okay, for chlorine anion, for chloride anion, since it is a weak conjugate base for hydrochloric acid, kan, sebab strong acid will produce weak conjugate base. So weak conjugate base, they have no affinity for hydrogen ion and they have no tendency to hydrolyze with water molecule. Hence, no reaction also at the anion hydrolysis. So when there is no hydrolysis reaction for cation and anion, so nothing change. So the pH of the solution will equals to 7, which means the salt is neutral. Okay, tadi salt tu acidic menyebabkan solution tu acidic. So now sebabkan salt tu neutral menyebabkan solution tu pun neutral. pH dia adalah 7. Okay. Alright. Okay, so now we are going to look at the last type of salt, which is basic salt. Okay, so this basic salt is the product of the reaction of a strong base and weak acid. So we have an example here. Strong base is sodium hydroxide and the weak acid is HCN. So when these two react together, they will form salt, which is NaCN salt and water. So this NaCN salt will dissociate completely to Na plus cation and Cn minus anion. Okay, so Na plus cation is a weak conjugate acid of sodium hydroxide, kan? Okay, when when sodium cation is a weak conjugate acid of sodium hydroxide, it also has a low polarizing power because of its low charge and large size. So it cannot bond strongly with water molecule and cannot undergo hydrolysis and cannot undergo cation hydrolysis reaction with water. Okay, so no reaction happen at the cation. So let's look at the anion side. So anion, Cn minus anion, is actually a strong conjugate base of HCN. So it will act as a Bronsted-Lowry base to accept a proton from water when it hydrolyzes with water molecule. So now you see here Cn minus anion accept one proton from water to form HCN and OH minus aqueous. So now it has OH minus aqueous, which means it will contribute to the basicity of the solution. So we can say that the pH of the solution will be larger than 7 and the salt is basic salt. Okay, because it undergo anion hydrolysis to form hydroxide ion. Okay, hydroxide ion contribute to the basicity of the solution. Okay. Alright. So, you have learned three types of salt, which are acidic salt, neutral salt, and basic salt. So basically, the cation hydrolysis will contribute to the acidic salt, and the anion hydrolysis will contribute to the basic salt. Okay, so that is how the salt is formed from the neutralization process. Okay, all right. So now we are going to look at the second part of this video, which is buffer solution. So what is a buffer solution? So buffer solution is a solution which has the ability to maintain its pH when a small amount of strong acid or strong base is added to the solution. Okay, maksudnya kalau you letak strong acid ataupun strong base dekat dalam buffer solution, it will means nothing. pH dia akan tetap sama. Okay, and we are going to explain why is this happening. Okay, first of all, we are going to look at the types of buffer solution. So basically, there are two types of buffer solution: acidic buffer solution and basic buffer solution. So acidic buffer solution, it consists of weak acid and its salt, which is conjugate based. And the basic solution consists of weak base and its salt, which is conjugate acid. Okay, so let's look at the acidic buffer solution first. Okay, so as you know, acidic buffer solution consists of weak acid and conjugate base of weak acid. Okay, so we have an example here. So if we have an example of weak acid of HCN, it will have the conjugate base of NaCN. Dia punya salt dia, NaCN. Okay, so weak acid, since it is a weak acid, it will only undergo partial dissociation. However, the conjugate base will undergo complete dissociation. Okay, so if we look at the dissociation equation for the weak acid, since it's undergo partial dissociation, we will use the reversible half-headed arrow to show that it undergo partial dissociation. So HCN will react with water here to form Cn minus and hydronium ion. So it will form hydronium ion. So however, there will be high concentration of HCN at the end of the dissociation reaction because it's only dissociate partially. So masih banyak lagi HCN yang ada. Sebab sikit je HCN yang dia baru dissociate. Okay, so dekat sini masih ada high concentration of HCN due to its partial dissociation. Okay, that is for weak acid. But how about conjugate base and NaCN? So conjugate base of weak acid will be undergo complete dissociation. So if you see here, when an ACN undergoes complete dissociation, it will form Na plus and Cn minus. Okay, so this will contribute to the high concentration of Cn minus ion in solution due to the complete dissociation of NaCN. Okay? Alright. So, for acidic buffer solution, there are two cases that we are going to look into. So the first case is when there is a small amount of strong acid H plus is added into the buffer solution. So let's look at the first case first. Okay, when you put the H plus, when we add a small amount of strong acid H plus is inside the buffer solution. Okay, so we still use the example HCN tadi . So now the Cn minus ion, which is conjugate base in the buffer solution, will react with the hydrogen ion sebab negative react with positive kan. Okay, so it will have an equation Cn minus aqueous react with hydrogen ion aqueous to form HCN aqueous. Okay, alright, dia form acid balik lah kiranya kan, betul? Okay, dia form weak acid balik. So now it will result the concentration of Cn minus here decreases and the concentration of HCN minus and the concentration of HCN increases. Okay, but since HCN is a weak acid, it will result in a very small degree of ionization. Okay, since it is a very small degree of ionization, the pH of the solution will be not much affected since the change in concentration of H plus is limited. Sikit je kan. So tak ada effect pun dekat pH dia. Okay, same goes when the small amount of strong base is added. Okay, bila strong amount of strong base is added, HCN, weak acid tadi ni, yang in the buffer solution will react with OH minus ion. So we have an equation here. HCN react with OH minus to form Cn minus and H2O liquid. Okay, so what happened after this reaction happen? The concentration of Cn minus increases kan sebab banyak Cn minus form, and the concentration of HCN decreases because it already react with OH minus ion. And now, what happened to the concentration of OH minus? It will decreases due to the reaction with HCN. Okay, so now the pH of this solution also is not much affected because the change in concentration of OH ion is limited. Okay, so tak ada beza sangat. Alright. Alright, now we are going to look at the Henderson-Hasselbalch equation. So we use this equation to find the pH value of the acidic buffer solution. Okay, so untuk acidic buffer solution, okay, contoh ni kita ada general equation sini lah. Weak acid plus water, it will form H2O plus and A minus ion, for example. Okay, to calculate the pH of the buffer solution, we use the Henderson-Hasselbalch equation. So Henderson-Hasselbalch equation says that pH of buffer solution is equals to pKa plus log concentration of conjugate base and the concentration of weak base. A weak acid. So concentration of conjugate base and concentration of weak acid. Okay, so it's very simple. So in the next video, I will show you how to use this equation. Okay, next, we are going to look at the second type of the buffer solution, which is the basic buffer solution. So Basic buffer solution pula, it consists of weak base and its conjugate acid. Okay, so now we have for the example NH3 for the weak base and the conjugate acid is NH4NO3. Okay. So weak base macam biasa, they will undergo partial dissociation and the conjugate acid will undergo complete dissociation. So for weak base which undergoes partial dissociation, it will form NH4 plus and hydroxide ion. Okay. So however, since NH3 only undergo partial dissociation, there is still high concentration of NH3 in the solution sebab NH3 cuma partially dissociate. Okay? Okay. However, for NH4NO3 salt or conjugate acid, it will undergo complete dissociation to form NH4 plus aqueous and NO3 minus aqueous. Okay. So now it has high concentration of NH4 plus ion dalam solution disebabkan complete dissociation of NH4NO3. Okay. So same as acidic buffer solution, there are two cases for this basic buffer solution. The first case is when you add small amount of strong acid, which is H+. So when you add H+, okay, so NH3 weak acid in the buffer solution will react with it. Okay, so it will have this equation. NH3 aqueous react with hydrogen ion to form NH4 plus aqueous. So it will result in the concentration of NH3 decreases sebab dah guna untuk react with hydrogen ion and the concentration of NH4 plus ion increases. Okay. So it will also make the concentration of H plus ion decreases. Sebab apa? Due to the reaction with NH3. Okay, sebab tadi NH3 dia react with hydrogen ion kan. So menyebabkan hydrogen ion punya concentration pun decreases sebab dia berlaku reaction dengan NH3. Okay, so dekat sini, since the concentration of NH3 decreases and the concentration of NH4 plus increases, dia macam tak ada beza tau. Dia macam saling top up menyumpap. Okay, bila saling top up menyumpap, pH of the solution is not much affected. Okay, sebab change in concentration of H plus is limited. Okay, sebab tak ada beza sangat pun. Okay, sama juga. Untuk case 2 yang small amount of strong base OH- is added, yang akan react adalah NH4 plus conjugate acid dalam buffer solution. It will react with OH- ion. So if we have this equation here, NH4 aqueous react with OH- will form NH3 and water. Okay, now here we can say that the concentration of NH3 increases. However, concentration of NH4 plus ion decreases. So the difference in concentration of H plus here also does not give much difference. Okay, so now NH3 is a weak base that result in a very small degree of ionization. So menyebabkan pH of the solution is not much affected sebab change dalam concentration of OH- is limited. Okay, limited lah. Sebab kalau you tengok pun concentration of formation of NH3 and NH4 plus pun saling top up menopap. So macam tak ada beza sangat pun in the difference in the concentration of OH-. So the pH will remain as it is. Okay, macam it's just a very really small changes which doesn't really matter. Okay, so it will maintain its pH as it is. Okay, so now for basic buffer solution, we also use Henderson-Hasselbalch equation to calculate its pOH. Okay, so bila kita calculate pOH, so bila kita bolehlah calculate pH juga kan? So sama je lah. Kan betul tak? So, tapi untuk calculation untuk basic buffer solution, so it is how you do it. Okay, so POH is equals to PKB plus log concentration of conjugate acid here. Okay, react with weak, divide by concentration of weak base. So this is how you calculate the POH for the weak, for the basic buffer solution. Okay, so when you do the calculation later, you can assume a few things. The first one, you can assume that the concentration of the conjugate acid here, or a conjugate base, is equal to the concentration of salt that you produce, since salt undergoes complete dissociation to form conjugate acid and conjugate base. Okay, and you also can assume that the volume of salt is too small and also can be negligible. Okay, so there are a few assumptions that you can use when you're doing the calculation after this. Okay, so that is all for part 2. Okay, so the video for calculation of buffer solution will be uploaded after this. Okay, so yeah, so that is all for the salt hydrolysis and buffer solution. Okay, next time we are going to cover chapter 7.2 titration pula. Okay, so don't forget to do your tutorial question. I think the tutorial question in the tutorial book for salt hydrolysis and buffer solution, yang bukan calculation, yang calculation tu jangan tengok dulu. Yang soalan 15 dengan 16 if I'm not mistaken, it's quite simple. You can refer to these notes here or refer to the lecture slide notes to answer the question. Okay, it's quite simple. You just have to explain the buffer solution and explain about the salt hydrolysis, which mainly all in the notes. Okay, but for the calculation, you can wait for my next video. Okay, and what we call it, don't forget to complete your tutorial for 7.1. Okay, so untuk kelas K7T3 yang akan ada lab after this with Puan Ila, so you will discuss, you will learn about the calculation for buffer solution as well as doing the tutorial. Okay, so make sure completekan sekali lah tutorial tu. Alright, for K73, no worries, I will still make video for you. Okay, so that is all for today's tutorial video. We'll see you on the next calculation buffer solution punya video. So yeah, see you, bye bye. Assalamualaikum.